The question says that a regular hexagon of side 10 cm has a charge of 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagon. Now the system of charge here is a hexagonal pattern. Now on each vertex of the hexagon there is a 5 microcoulomb charge present, and we have to find out what is the potential at the center of the hexagon. From the previous exercise we also know that potential at a point P, which is at a distance r from the charge Q, is given by Vp equals to kq by r, where q is the magnitude of the charge and r is the distance of separation between the point of our interest and the charge, and k is the Coulomb's constant. Now for the system of charges, this potential is just the algebraic sum of the contribution of individual charges to the potential, because potential is a scalar quantity. Now for this system of charge, that is a hexagon pattern, we will have to find out potential at the center. Each side of hexagon makes 60 degree as a center, which makes it an equilateral triangle. Now for the equilateral triangle, each side is same, that is each side of hexagon is 0.1 meter, so the distance of center from the vertex would also be equal to 0.1 meter. Now finding out potential of the system, we can write it as Vp equals to summation of kqi by ri, where I varies from 1 to 6 because there are 6 charges, and that would be, since the distance of separation is same, so we can simply write it as 6 times k q by r, where q is the charge on the vertex and r is the distance of separation between the vertex and the center. Now that will give us a value of 2.7 into 10 to the power 6 volts. Thank you.